Hey everyone, we're back with 1994-85, and we're going to be solving this problem again. Don't forget to use these videos as a way to check your work and not necessarily learn from the videos, but maybe to assess whether or not you're understanding it, maybe get a hint, and moving on. So here we have a circle inscribed in square shown in this figure. The circumference of the circle is increasing at a constant rate of 6 inches per second. So I'm going to underline that. As the circle expands, the square maintains the condition of tangency. So that means it stays there as it expands, which is kind of cool. So we got a couple things we have to do. Note the circle and radius. A circle with radius r has circumference 2 pi r and area pi r squared. So they were kind enough to give you the equations or the formulas this time. So find the rate at which the perimeter of the square is increasing. Indicate the units of measure. So the first thing I'm going to do is I'm going to label my diagram. I know we have a radius here of r. So if the radius is r, that means the side of the square is going to be what, everybody? You got it, 2r. And then over here is also going to be 2r, which is lovely. So we have 2r and 2r. So find out which perimeter of the square is increasing. So if I have a here, my perimeter is going to be adding up all the sides, the distance around. So it's going to be 2r times 4, or 8r. And I need to find some stuff. Well, I didn't identify. What did I identify? I know that we have a DC, or our circumference. DC dt is 6 inches per second, which is cool. And I think that's all the information we're given. So let's find the derivative here. dp dt equals 8 dr dt. Well, that's easy enough. Now I need to find dr dt. I don't have a dr dt. How am I going to find dr dt? Huh. Well, I have a circumference here, and I have the dc dt, so maybe I can use the circumference formula, 2 pi r. If I take the derivative of this, I get a dc dt, which is kind of cool, and then I get 2 pi dr dt. Oh, that's what I'm looking for, dr dt. I know dc dt is 6. We have 2 pi dr dt, so what happens? Divide both sides, and I have a dr dt equal to 6 over 2 pi, or 3 over pi. So inches, this is inches per second. So now we have our dr dt. So our dp dt is going to equal 8 times the 3 over pi, which is 24 over pi inches per second. Don't forget your units. All right. So I'm going to advance to the next screen, and I'm going to show you how to do B. But again, try it first. So I'm going to read it. At the instant when the area of the circle is 25 square inches, so when this area of the circle is 25 square inches, find the rate of increase in the area enclosed between the circle and the square. So this area right here, and there, and there, and there. So that's what we're trying to find. All right, indicate units of measure. So look at all that information. Okay, we have a circle, we have a square, so now we have to go do solve B. Oop, sorry. Should have gone there. B. First, we need to come up with an area formula. So let me go back. So we're going to need to find the area of this shaded region around. So I have the area of a square, and I have the area of a circle. And what do you think we have to do to come up with the area of that shaded region? If you thought subtract, you would be correct. So I have the area of the square, which is going to be 2r squared. We have the area of the circle, which would be pi r squared. We're going to subtract them, so the area of the entire thing is going to be 4r squared, because I'm squaring this, minus pi r squared. And we need to find dA dt. So take the derivative. dA dt, 8r dr dt, minus 2 pi r dr dt. So let's plug in what we know. Do we know dr dt? Let's look. Do we know dr dt? No, wait. 3 over pi, can we use that still? Of course we can. It's still the same problem. Still the same situation. So we have dr dt. Do we have r? No, we don't have r, but can we find r? Remember, this is taking place when it tells us when it's 25 pi square inches. So I have pi r squared equals 25 pi. By looking at that, I can see that r squared is 25, or r is 5. So let's use that. So we have 8 times 5 times our 3 over pi minus 2 pi times times 5 dr over dt. You can do the rest, the substitute and solve. We did the diagram, we have the rates, we have the equation. We took the derivative, substitute and solve, and you'll get your answer. And I think you get something like 120 over pi minus 30 inches squared per second for your dAdt. Well, this is 1994 AB5, and I hope you enjoyed it, and Johnstone out.